So we just did one-to-many relationships. Now we're going to do many-to-many. And we already discussed what it is. It's a recipe contains many ingredients, and ingredients belongs to many recipes. So how do we model those things together, right? There's not like a one table to one table relationship where if I have something here, it exists over here. I need another intermediary. So we're actually going to add a third table to model that. So let's go ahead and do that. We're going to create a table called recipe ingredients. It's going to have a recipe ID. That is an integer that references recipes, recipe ID, on delete, no action. Why am I putting on delete no action here? If I have an ingredient and I delete like the connection between the recipe and the ingredient, I don't want to delete both recipes and the ingredient, which then have cascading deletes, which then go back and delete things. You would eventually kind of like wipe out your entire database accidentally. So if you're trying to delete a recipe, basically what you're saying is like you have to go clear out the recipes ingredients table first, all of the connections first, before I let you delete the recipe. So you would start by deleting things out of this table first before you go delete recipes or ingredients. Okay, I'm going to have an ingredient ID, int references ingredients on its ID, on delete no action. Okay, you need some sort of primary key because every table has a primary key, but I could just insert like a connection ID or something like that, or just give it like a normal ID. However, we're never going to query this table for a specific connection. We actually don't really care about the individual connection objects. We care all about is just joining the two tables using this intermediary table. So instead of having some third ID, what I'm going to do is I'm going to have a combined or a compound index that combines them together and asserts their uniqueness. So I'm going to say constraint recipe ingredients. I'm giving it a name. That's what this is. PK for primary key. Primary key of recipe ID and ingredient ID. You need a comma. So what this line is asserting is the primary key of this table is the combination of recipe ID and ingredient ID. That should be guaranteed unique in this table because it doesn't make sense that flour would be the same ingredients twice in one recipe. It's just the one recipe, right? So if I try and insert like egg twice into the cookie recipe, it's going to say you already have this in here. There's no need to connect it again. You don't need multiple one connections. You have one connection. That make sense? Okay. So now if I look at my recipe ingredients, I have this recipe ID and ingredient ID, and then my foreign key constraint is that recipe ID exists in recipe, the ingredient exists in the ingredient one, and the combination of the two is unique. This is how you model many-to-many relationships using SQL. All right, let's go ahead and go insert some things into that database. I'm just going to copy and paste this because it's not that interesting. Okay, so now if I select star from recipe underscore ingredients, I have some rows in here. These are guaranteed to be in the ingredient. These are guaranteed to be in recipe. However, the connections themselves are wholly uninteresting, right? I would never want to return this to a user. I want to see what's in the recipe, and I want to see what the ingredient is. But notice I have 1, 1, 1, so these are all the same, and then I have 13 and 13 here. So ingredients can exist in multiple recipes. Recipes can have multiple of the same ingredient. It's just the combination of the two that's unique. Okay. Now let's say instead of having recipe ID 1 here, I want to have the actual recipe. Instead of having the ingredient ID here, I want to have the ingredient. How do I do that? Joins, you might have guessed that. Good job. But the second thing is we have to do multiple joins. We have to join a couple of times. So we're going to select i.title, and you can actually give them names if it's a little bit easier for you. So that's what this as keyword does. Select the ingredient title as ingredient title, if that's clearer to you. This is just going to be the name of in the table that it returns to you, right? i.image as ingredient image. i.type as ingredient type. Okay, so first thing is I'm just going to do the ingredient part first, and then we'll go back and we'll do the recipe one. So from recipe ingredients RI, inner join ingredients I on I.id equals RI.ingredient ID, where we'll just grab one of them, RI.recipe ID equals 1. And what did I mess up here? Recipes ingredient. See, I mess this up all the time. It's recipe ingredient. There we go. So I went and grabbed all the ingredients for recipe 1, which I think is cookies. So in case you didn't know, carrots, cauliflowers, and chicken go into cookies. These are nonsensical recipes, so don't worry too much about that. So this got us all the ingredients, but it doesn't tell us what the recipes are, right? So how do we get the recipes in here? We're going to have to do another inner join. So let's do that. We're going to do, oh, okay. Let's do this in code because this is going to be so much easier for you to visualize this. Change layer mode SQL. So I'm going to do select i.title as ingredient title. We're going to do i.image as ingredient image, and then we're going to do i.type as ingredient type, but we're also going to grab from R, which is going to be recipe, we're going to grab r.title as recipe title. And what else do we have in that? Recipes, the body. So we'll grab the body as well. So we'll grab r.body as recipe body. And if you want, you can grab the IDs as well. r.id as RID and I.id, except this is recipe ID. Recipe ID. And I.id as IID. Okay, we're going to do a from. We're going to do recipe ingredients RI. Okay, you have to inner join I'm going to try and space these out a little bit so it's a little bit easier to read. Inner join ingredients I on I.id equals ri.ingredient ID. Okay. Inner join again. Recipes are on r.recipe ID equals ri.recipe ID. In theory, you could do a natural join here, but don't. And then here, you could, after that, you could put your where clause if you wanted to. You could say where ri, whatever, blah, blah, blah. We're not going to do that. We'll just grab all of them. And let's see if that works. And there you go. So the recipe here, cookies, cookies, cookies. This is coming from the recipe table. The ingredients type is coming from the ingredients table. And we have all of these connections that exist because of that recipe ID, or the recipe ingredients table that exists there in the middle, right? If you remember, we inserted, where are we? Up here. We inserted 5 different rows of just numbers that correspond to both tables. And then we used the joins here to grab the information from both tables, so therefore we can see all of the ingredients in all of these recipes. So 5 insertions, we have 5 rows here that matches up. It's a lot, I know. But this is kind of how you use these like relational tables to join information to build each other up into these big things. And then using foreign key constraints, we can kind of guarantee that everything stays in sync. You can see here when you start joining a lot of tables, it's really useful to have these short table names. Frequently people make them 1 to 2 letters. It's probably a little bit excessive. In a very short query like this, it's probably fine. But if you're writing like 100-line queries, which is not that uncommon, you probably want to have a little bit more description. Like I might call this like ing and recipe or something like that, but typing out recipe ingredients 50 times sounds wholly unappealing to me, so I don't know. It's kind of up to you what you want to do. But yeah, this is how you model many-to-many relationships.